Hello, everybody. This is Mr. Bowman. I'm going to go over the area model and how we use that to teach multiplication to where eventually our students will go and multiply using what's called the American algorithm or the traditional algorithm. This is a progression. If you read up here, it's a progression. But hopefully, they'll start with the actual base 10 blocks and so on, and eventually work their way to what's called a symbolic representation of the area model. I want to walk you through the what's called a concrete slash pictorial process, and then I'll show the abstract and what that kind of looks like for us. Okay. So this right here, I'm going to go to what's called Polypad, and I kind of had pre-worked it out for myself so I can kind of do a better job when going over it. I don't want these videos to be too long, so I'm trying to make this kind of quick. What I'm doing here, if you're wondering here, is I'm doing what's called a multiplication T-chart, or basically just the sides of a rectangle. So what the area model is just us using the area of a rectangle to represent multiplication. So what we got here in the example on that you see up here, we got 12 times 13. Now the way it was modeled, they put the 12 up here, which is fine. So 12. So these are called base 10 blocks. Now we're going to use these to build the sides of a rectangle. So that side is 12. You see it? And since I'm using what's called a virtual manipulative, this is concrete slash pictorial. It's kind of done at the same time since it is kind of a picture. And I can draw it out for you too if you guys want, but I draw really, really bad. All right, so here we go. The other side should be 13. It gets moody. Technology gets very moody and will start moving around on you, but it's okay. And there it is. I have the sides of my rectangle, my length of 13 by 12. I think that's a 10 plus 2. It's a 10 plus 3. And then all we do is we fill in the area. What is 10 times 10? 100. 10 times 10 is 100. What is 10 times 2? 20. Bam, bam. We fill in the 20. What is 10 times 3 or 3 times 10? 3 times 10. That's 30. I had a parent tell me, well, you can't get the wrong answer when you do it that way. And I told him, yeah, you're gonna get the right answer every single time if you use the manipulatives. And he goes to me, well, that's not right. Okay, so why not? He goes, well, I mean, you don't get the wrong answer. I go, well, that's a good thing. And then you got to think about it for a little bit. Well, so they're going to get the right answer every time. Yes. Oh, so they're not going to get the wrong answer. No, sir, they get the right answer every time with the area model. Well, then that's a good thing, I guess. Yeah, yes, sir. They're going to be successful. All right, so this is 20 here. This is 30, and this is my 6. These are called my partial quotients, 100, 30, 20, and 6. They give me that 156. Some kids see it. Here's my 10s and my 10s, and they'll see 100 plus 50 plus 6 to get 156. Now, other kids might want to draw it out, and that's perfectly fine. So this will be the pictorial representation. They'll come out here. They'll give me like a 10 like that. 1, 2, 3. And tell you what I'll do here. I'll do just the sides first. And you'll see me do everything else. Filling in that rectangle. This is a 10, 1, 2, and then you just draw it out this way. And the reason I stress the picture model, this one, what I'm doing right now, is because the state will test them with the picture. Right? And there it is. That is 10. I'm sorry, that is 100. This side is 20. This is my 30. This is my 6. Same answer. And eventually we eventually start doing it this way. And I'll just draw that out real quick. You should see the QR code right here. And our kids will eventually multiply this way. Now what I do, and notice the box is a little even, is I will draw it out the way it kind of looks here. Like the sides are a little more narrow over here. 10 plus 3 times 10 plus 2. And then they can fill it in. 10 times 10 is 100. 10 times 2 is 20. 3 times 10 is 30. 3 times 2 is 6. And they'll still get the exact same answer every single time. Here we used what's called the concrete pictorial together. Concrete pictorial. together, and then we go to what's called abstract, which is this part. This is my abstract. And we get the right answer every time. The majority of our students are more successful using the area model. We guarantee that. And then where the kids that struggle with the American algorithm can always come back to the area model and get the right answer. All right, hope this helps.